naive Bayes is also data-driven. We just make statistical analysis on the input data. So it's not a model-driven, just like the KNN. There's no assumption for the data. So we don't care about the previous knowledge, background knowledge. We only care about data. So this method is developed by the Thomas Bayes, so which I call naive Bayes. This method has the idea to find the same values for the predators so they can make estimation for the new input. Yeah, so we need to make analysis on the input data to determine the prevalence class among these input records. Then you can assign the class, that predominant prevalence class, to that new record. Okay, this method requires categorical variables. Yeah. And you need to make a translation for the numerical variables to be categorical variable. It should be bind. It should be bind and converted to categorical variable. And this method can be used to huge amount of data sets. Yeah, it's very efficient because the calculation very easy, so the performance very fast. We have example for the spell checking programs. Assign your misspelled words to one class. This class is called misspelled word class. Yeah. So we can find the records with the same predator values to the current new input. So we need to calculate the probability of belonging to one class C. If the probability is high, then the new record will be classified to that C. Actually, sometimes it's very difficult to find a good match, exactly match for the predators with a new input from inside the already available cases. And you need to make the estimation from this probability calculation. This naive Bayes method will assume the independence between the predator variables. They are not related. Yeah, so we can use the probability equation to calculate the possibility. So we need to apply the multiplication rules inside that equation. This S rules will be the equation. So we can find the same probability that records belong to class C for the given predator values without the limiting calculation to records that share those same values. Yeah, so you just calculate the probability values for that equation. So this will not I will delete this slide. Actually, update with new slides. Actually, we will calculate the probability value CI, for the possibility of that new record to be assigned to class I. It can be calculated by this equation. The top will be the multiplication between two possibilities. One will be the S1, S2, SP on the condition ith class. Okay, a PCI, the probability for the class CI. On the bottom will be the for the case of this multiplication for all the classes from C1 to Cm. It will be summary of this multiplication. Actually, we can make this calculation simpler if the assumption of independence for the predator is valid. So we can split the PSY to SP on the condition CI. It can be expressed by the multiplication between P possibility values. For example, PS1 on the condition CY, PS2 on the condition CY, come onto SP on the condition CY. And the same calculation can be applied to every one class from C1 to Cm. So on the bottom will be the summary on the all the classes, a summary of all these multiplications. Yeah. In this equation, the Ci is the class, the C1 is the class C1. Ci will be class ith class. Si will be the predator. Yeah. S1 to SP will be all the predators for the input. So there will be one output for the decision and whether to take it or not. So we have the target variable for the output is fraud or not fraud. So here will be for the example financial fraud. Yeah. So only just one output, very signal with two possible value, fraud or not fraud. The predators as input, we have two predators. One is the prior pending legal charges, whether or not. So yes or no, just two values. Net size of the firm can be the large or small, two possible values. So we have this table for the database. The charges is predator, size also predator, the outcome just the categorical variable. So all the fields, all the variables are categorical variables. Yeah. So if there's one numerical variable, you need to make a bin, make a translation for the numerical to categorical variables. Okay, this for this example, we can build the goal is to classify a small firm with charges fired as fraud or not fraud or truthful. Here we have the one examples for this possibility. Yeah. For the charges is yes, size company is small. The possibility to be fraud is 50%. Yeah. Actually, it can be calculated from the previous example. So we say we can just copy this. Copy this will be convenient for the analysis. Okay, we can find the cases, all the cases with these two features. The charge is yes, the size is small. The charge is yes, okay, there are 4 yes, and also small 1, 2, and only 2. Okay, but inside these 2, the float is 1. Yeah, so be 1 divided by 2. Yeah, so this will be 1 divided by 2. So this will be 50%. Yeah, that's why it is. Yeah, so this fraud analysis is based on the number of cases that has charge is Y, size small. Yeah, so the fraud is Y, but it's chosen among 2 cases that has these features as a condition. So it's a conditional probability. Yeah. Okay, next one is the second method. We can use the equation we introduced, the naive-based calculation. So we can calculate the first one. The charge is yes, based on the condition fraud. Okay, times the charge, the small has a condition fraud, and time the possibility just one fraud. Actually, we have these results. So for the convenience, actually we can calculate individually from that table. Yeah. We can calculate separately, so it would be convenient for you to understand why we have that values. Yeah, for the first one, we find all the fraud cases. Fraud case will be the bottom 4. Then we try to look for the number of cases the charge is yes. And from these 4, there are 3 yes. So this value will be 3 divided by all the 4. So it will be 0.03 divided by 4. Yeah. And for the case, the fraud from we know is 4. So we have divided by 4. But for inside the 4, there's only 1 small. So it's 1 divided by 4. Okay. For the fraud is only 4, but it's among all the cases 1, 2, 3, 4, 5, 6. So be totally 10. Yeah. So we have this. Then we multiply these 3 together. You will obtain this. Yeah. It will be this. You can obtain the same results in the same way to calculate the other group calculation for the truthful. Yeah, it's not the previous for the fraud. Now you calculate truthful. Yeah. Then you can use the equation like this. And obtain the fraud based on the condition charge is yes with small company. So the value will be this one divided by the summary of these 2. So it's 53%. It's larger than 50. So we say it's truthful. Yeah, larger than 50 would be truthful or fraud. Oh, see. So the fraud is 53. So has higher possibility to be fraud. Yeah, because fraud is 53. So if you calculate the possibility to be truthful, the value will be complement to this number. That will be 47%. Yeah. So fraud possibility is higher. Okay, we have the probability estimation actually this one calculation does not differ greatly from the exact number, because this is based on the estimation from all the cases in the database. All records are used in the calculation. So it's why estimation based on the records, this will be more accurate as the statistical results. So this makes calculation practical in most circumstances. So this naive-based method is very popular in a real situation application. So this method has one limitation. It assumes the predictors are independent. So that we can use that equation directly. If you don't assume the independence, you have to use this method. Sorry, this is not the method. I have to use the previous one equation. Use this equation. And this calculation will be tedious for this one. But using this conversion, simpler format will be faster for the calculation. Okay. We have this conclusion. This naive-based method just work on all the data with the assumption independence. Advantage will be that it handle the purely chemical variables. We will not support the numerical variable, have to make conversion for the numerical to be twin variables. And the computation very efficient, very fast. It's not recursive iterative calculation, just one straightforward calculation. It also has shortcomings because this method based on the statistics on the data in the database. So it requires huge amount of records to make sure the estimation is accurate. But it has one problem. If the predictor category is not present in the training data, the accuracy would be very low. So it will assign a zero probability of the response, ignoring information in other variables. So this is not. So just find a match inside the database. Just matching inside the database. Then obtain the prediction. Oh, the classification. Oh, prediction, because this is one numerical value, that's 0.5, so it's one prediction. Okay, the example for the flight delays, it contains several predictors, day of week, origin, destination, period, one output, delay on yes or not. Here we have the code that will read the data from the database, flight delays. Then it converts the numerical variable to be chemical variable by calling the S type. So this converts the day week variable. Okay, next one to convert the days DF flight status to be chemical variable. You can use these two methods. Just use a dot that field name. But the next one is use a string, the title of data variable for the data extraction, because it contains one blank. If you use the previous method, you should not have one blank between the words for the name. You can use the underline for the name, so you can use this way. Okay, next we will process the numerical variable for the CRS departure time. This is numerical value, so we just divide the time by 100, so we can bin the numerical value into 24 hours, from 1 to from 0 to 24, 23. So I'm not sure. So we can create the predator array using these converted results. Day, week is clerical variables already. Then will be the CRS departure time is binned numerical variable. Okay, origin is original value. Destination also original value, so it's a clerical value. Carrier is also clerical. What kind of flight it is? The flight status, you can see that one blank between two words. This is for the output. This is already translated using this line statement. Okay, next is to convert the predators into dummy variables. Okay. Then this dummy variable will be the x. For the flight status, this output will be converted to the clerical variable, and this will be the y. Okay, y categories will be the classes. So return the classes definition from the y. So to figure out how many categories inside the y, the flight status, so we can build the classes from the output. Then we split the data into validation sets, training data sets. We set the test ratio size is 40%. Then we call the function multinomial MB. MB is naive Bayes, multinomial naive Bayes. We set the alpha parameter to be 0.01. So then we can build the Bayes naive. Then we apply this model to the training data. Okay. Then apply the trained model to the training data, training predators. So we can obtain the prediction results for the training data. Also apply the trained model to the validation predators. Then we obtain the predicted results for the validation data. Okay, this predict probabilities to predict the probabilities. And next one predict the class membership. So a little different for the prediction. Be careful about this. That's with probability ranking are more accurate than the active probability estimates. And good for the application using lift response to the mailing. Actually, we discussed this in module 5. Okay, summary. No statistical model involved. We just based on the data-driven method. This naive base, similar to the KNN, just work on the input data, will not consider the background knowledge. Okay, so that's this. So we can go to the example code. And we also have one homework for the base. The homework is this. Just based on the example in the lecture. Okay, this one table. You can calculate the possibility for the fraud on the condition charge is no large company. The other one probability is truthful based on the charge no large. And whether it's yes or no, you can use this exact-based model to calculate these values. So they just directly obtain this value from that table. Yeah, just now. Already show this. Next one is use a naive equation. Yeah, actually we have example in a lecture. Just do this way. And just do in a similar way. Okay, so the first one question just calculate directly. Yeah, just firstly you find this pattern. Okay, then to choose the number for that output fraud. So we can calculate 0.5. The next method you need to calculate individual probability. Then you apply the multiplication and the naive equation to obtain the possibility. Yeah, this is not difficult. Yeah, this first method, this second method. So this will be method 1. It's method 1. Method 1. Okay. Method 1 is that computation. Okay. This is the model 2, method 2. Also naive calculation. Yeah. Okay, you just follow these two examples for the homework. Okay, it's not difficult. Yeah, actually, I have solution here. You can see my solution. For the first one, we just find the pattern of this one. And inside pattern, how many is fraud, how many is truthful. So there are totally 3 cases. Charge is no, and common is large. Yeah, but the fraud is 1. 2 is truthful. So has these 2 values. The next method, naive-based method, you need to calculate the several possibilities according to different patterns. Then you apply the naive equation to obtain these two values, 2 probability. Okay, so you can obtain by yourself. It's not difficult. Any questions? Okay, you can check the code by your own self because today we don't have enough time. time almost due. You can open the example naive base. Because this homework does not ask you to work on the real data. Yeah, actually, I strongly suggest you to try the real data. I will create a new question for one example to try the code. Yeah. I mean, maybe next time I will build one homework for this naive base method. Okay, any questions, please? Okay, we just review quickly. So because we already finished this, you can see just the import instructions, then we extract data, then apply the conversion of a categorical variable for the day, week, depart time. Then we calculate the predictor and outcome variables. Then we convert the predictors to be dummy variables. Yeah, predictor is a categorical variable. Change it to dummy variables. Just now we discussed example in the previous lecture. Yeah. We can just use this get dummies to directly translate that variables. And we translate the outcome to be integer type. Okay, we can create the classes, just two possible, on time or delayed, just two possible values for the class. You can also create this class from the outcome variables. Yeah. Actually, we have this in the later, and we will discuss in the later codes. Then we split the data into two groups. Then call the multinomial naive base function as the model with the parameter alpha 0.01. Then we fit. We will training this model using the training data. Then use this trained model to predict the probability on the training data and the validation data, and also predict the output class for the validation data and training data. So we have this. Okay, next will be the same. Okay, the same will be previous. Only difference will be the creation of the class. Yeah, it creates a class from the output categories. Yeah, categories features. Yeah, so this is one better way. It's not necessary to create a class by oneself. You just create using the one equation. The other the same. Okay, next will be the split the data. Okay, the same before. I will set the precision option to be 4, and we will try the individual predictor inside predictors. So we can have this pivot table. Yes, this others not in the lectures. Yeah, about the previous several example very important. You can this one code is very important. You need to convert the numerical variable to categorical variable, being the numerical variable to the character variable, and also translate the character variable to dummy variables. Then you call the model of multinomial naive Bayes to train the data. Then use the train the model to predict the training set data, validation set data, or new test data. Okay, that's all. Any questions? Okay, we have the homework Lec11 naive Bayes, and that is due November 6th. You can check this assignment. There are two problems. The first one for the coding for one database, flight delay.csv file. This code is available in the lecture example. So I just let you to read that code and study and follow that example. Here I just ask you practice that one example. You will finish several steps training the naive model using the training set. So before that, you need to split the data into two groups, training set and validation set. Then you can extract records from the validation set and show the intent, just one record. In that source code, it provides the prediction on whole validation set. But here I just ask you just predict on one data, on one record, one line, or one row. Then apply this model on the data, show the actual output and the predict output. And you can show just the test, whether they are same or not. Okay, the example, okay, you need to start up the navigator. Yeah, here we need to wait several seconds. When you use this Anaconda navigator and Jupyter, you can click the Jupyter launch. Before this start up this Anaconda navigator and Jupyter, you have to install all the packages that's required by your code. Yeah. The package can be installed through the prompt, command prompt in the Anaconda 3. You choose the Anaconda prompt. You can use the conda install the package name, or you can use pip install the package name. Yeah, the two-way, other way it can work for your project. So here I will go to the folder. It's Lec11. For the homework assignments, you can follow the table 8.4. This is for the data analysis for the flight delays. I usually prefer you to try the second group of data because that will create the classes directly from the data of the Y. But in the previous one code, you have to input the output by your own self. The next one code is more convenient. So for the solution, you need to copy the import. Okay, before that you need to create the new notebook Python 3. Okay, you paste the input. Okay, then copy the code for the database days. Copy all the codes. Like this. But here you can see obtain the data. We need to convert the data type for different fields. Daily, week to categorical data, flight status to be categorical data. The time will be bin into categorical variable. And then we create the predators using these 5 fields and output just one flight status. Okay. Then we create dummy variables from these predators because these predators already be the critical variables. Then we can convert to dummy variables. Okay. Then we create a y, just one output variable. Okay. Class is created from the categories in the output variables from that column of output variable. Then we use the split, train test split, using the parameter test ratio, test split ratio to be 0.4, 40%. Then we apply the multinomial naive Bayes model using parameter alpha 0.01. Then we use this model to train this model using a training dataset, S-train, Y-train. After we train the model, then we use this trained model to predict the train input of train predators. And we can also to predict the value for the validation set. Okay. So we can call the predict probability to obtain the probability values for the prediction of the training data set and the validation set. The next group will be for the prediction of the output for the validation set and the training data set. Actually, the questions do not require you to predict whole sets, just one record. So for that, we need to enable this. For this not the solution we want. Actually, I want you to use one record from the validation sets. So just use one record. So we can build the test data. We have to build the pd.dataframe. We'll build the frame from the data S-train. Or as validation, you want to obtain one row from the S validation. But we need the index value, just the first one. Yeah. Then we do this to the data for the analysis. So we can print the results of this prediction and validation. Yeah. Okay, the validation prediction data result for the prediction data, and also the actual value for this prediction data. So we can run the results. So this is not correct. I valid predict. Yeah, predict probability for prediction data. Yeah, we can see yeah, so you can see the predict results on time, the actual value is on time. Yeah, so this is the solution for the first one question. The second question is required to continue work on this one table based on two predictors, charge and size, and calculate the make prediction for the outcome. There are binary variable. The size also is one binary. The variable is also binary. So we can use the equation, use the table to calculate the p fraud with the condition charges is low, commonly is size large, and also the other one calculation for the truthful with charges is in size large. You can directly obtain these two values from this table. Yeah, just do this. Actually, for the charge in large situation, there are three cases in this table. And from this table, the fraud is only one, truthful only two, so obtain these results. And next one, use this naive Bayes model. You need to use this equation. So you need to calculate the several probability like this. The charge in fraud, in this case, totally charged in with a condition fraud. Fraud situation all are 4, and only one is charged in. Yeah. For the fraud, it's only 4, but the 3 are large. Yeah. For the fraud, only 4 cases from totally 10. The charge in, okay, there are totally 6 are truthful, but 5 charges is no. Yeah. So we can calculate this several probability, then we can use that equation to obtain these two results. This naive based modeling results. The third one is required to use the code in an example to calculate the naive based modeling results for these two probability. The code is available in an example. Okay, this is for the table 5. So to calculate the results, you need to copy this code. Yeah, copy this code. So we have a split, a new cell, create a new cell below. Okay, paste here. And we also have this import code because we have different question, maybe you start from different time. This is for the data of the delay df from this source data, but we have different table. Yeah, we have table of this homework. Yeah, we have to build the data for the data frames of the predictors and output. Yeah. So we can, so I just copy what I have done before. So I can create the training data. Before the data, okay, it's not necessary to split because we just work on the total data. Then we can make the calculation quickly. So it's not necessary for the split. So we build the data frame for the training data, and then we can iterate the predators and the outcome variables. Okay, so we have three fields for the original data train DF. Just three columns: outcome, size, and charges. Okay. Then we will calculate the output, outcome. The value counts divided by the total records. Okay, the next will be just one outcome. Flight status. So inverse the sequence. So index will be the outcome. This for the pivot table. So this will derive the pivot table between the output variable and any one predator. So then we obtain the obtain the conditional probability using this pivot table. Okay, and based on the results, and we can calculate the probability. Just copy the code from here. This value, okay, we have to build that one new cell. Because this probability value based on this previous one cell. So we run the cell. We have to run this one. And run this cell, we can obtain the pivot table between charges, between outcome and the charges. Next one is the outcome and the size. So output with any one predator. And the first one is for the probability of the outcome. Outcome has two possible values: truthful or fraud. Truthful is 60%, fraud is 40%. So this the p-hat fraud is equivalent to the probability of fraud time the charges is in, but the condition is fraud. The condition fraud, the charge is in will be this one value. So we copy here 0.25. And for the other column is fraud. Okay, this row, but the size is large. So the value is 0.75 here. So we can obtain the first one probability for the fraud with the condition charge in size large. And the next one is for the truthful. Yeah, a truthful probability is 60%, so 0.6 copy here. Then next one is based on the P of truthful, the charge is in. So truthful, the charge in will be 0.83. And copy 0.83 here. Okay, the outcome is truthful, the size is large, and 0.333. Copy 0.333. Yeah. So we can print these two results here. The required solution for the P fraud with the condition charge in large. This will be the first one, P hat fraud divided by the summary. And for the truthful case, the P hat truthful divided by the summary. Yeah, so this will be what we want for the solution of the homework. So we can execute that, then we can obtain this value. Yeah, you will find these two results will be the same. We calculate using the hand. The hand results will be the first one 31%, second is 69%. From the Python code execution, you can find the first one 31, second is 68.9%. It's the same as 69. Yeah, so this was the solution. So you just copy the code and also the execution results to the assignments. Yeah. So we'll copy the first one. Because it requires the print of the case, we'll print test one in. Okay, then we run results. Okay, we will copy the execution results for this. So copy the source code and then paste the solution. Okay. You can make a screenshot of this, or you can copy directly. Yeah, just make a screenshot here. So it's the data, this for the predicted results, and the actual value for the output. So show the Python code, the actual input, output, and the predicted output outcome. So first one. The next one questions for the code, just copy and paste the code here. The results should be the same as the calculated result by your hand.